Hi everyone. In this lecture, we are going to solve a full-length new pattern JEE mains paper based on NTA pattern. So we will start solving this paper. So in continuation with this one, we will be having a series of lectures on solving JEE mains papers and NEET papers. So subscribe to the channel and press the bell button so that you will receive the notifications and continue to watch my video. Thanks for your support. So now we will solve this question paper. The first question reads out that a DC supply of 120 volt is connected to a large resistance X. A voltmeter of resistance 10 kilo ohm placed in a series circuit. So we will draw a diagram on this. So a DC, if there is a voltmeter, and there is some resistor, a high resistance. Voltmeter is 10K. The voltmeter is 10K. 10K is 10,000 ohms. And this one is X. You don't know what is this. The voltmeter, they say that it reads 4 volt. It reads 4 volt and this is 120. So if two resistors are connected in series, then the total EMF will be divided in the ratio of their resistances. So the potential drop across the 10K is 4 volt. So the potential drop across the voltmeter should be equal to, it will be divided in the ratio 10,000 is to X. So that means when you divide that ratio 10,000, that 120 will be divided into 10,000 is to X. 10,000 by 10,000 plus X times 120. So you solve this, when you solve this equation for X, you get 10,000 plus X is equal to, so this is going to be 4 volt. This is going to be 4 volt. So in that case, if you solve this one, you will get 10,000 plus X. 10,000 plus X should be equal to, this 4 cancels 30 times, so it becomes 30,000. Not 30,000 actually. 33 lakhs actually. 3 lakhs. 3 lakhs minus 10,000 is 2,90,000. So 2,90,000 is nothing but 290K. It's 290K. So the answer X is 290K. So this is the right answer. The next one is the next problem. The period of the satellite very close to the Earth is T naught. So T naught is directly T naught squared is directly proportional to, according to Kepler's law, T naught squared is directly proportional to R cube. And what is the period of the geostationary satellite? The geostationary satellite is approximately 7 times the radius. The orbital radius of the geostationary satellite is approximately 7 times its radius. So the time period of the square of the time period of the satellite should be equal to, so 7 times R the whole power 3. So when you, this is actually proportional to, so when you are going to divide this equation by this equation, you get Ts by T naught is equal to 7 the whole power 3 by 2. Whole power 3 by 2, which is 7 root 7. So Ts is equal to, 7 power 3 by 2 the whole times T naught. So this should be the right answer. The next question is, this is the first one, the second question, and the third question reads out. Aluminum and silicon, if the temperature is changed from normal temperature to 70K. The normal temperature is 300K. So from 300K, it is decreased to 70K. That means the temperature is decreasing. If the temperature decreases, then the resistance of metal will also decrease. And the resistance of semiconductor will increase. So that means that here aluminum is a metal whose resistance increases, and silicon is a semiconductor whose resistance will increase. So answer, this B option is the right answer. The fourth one, when a white light is passed through a dispersive medium, it breaks into various colors. Which of the following statement is true? So we know that the violet bends more than in you would have from your high school you would have seen in case of a prism when white light enters, the violet bends more and the red bends less. That means that the refractive index for violet is greater than for refractive index for red. So this means if the refractive index is more, then it is a very optically more denser medium. So violet is for violet, the medium is more denser than for red. So which means that the velocity of the light, the speed of the light in for violet is less than the speed of the light, speed of red light. The speed of the violet light is less than the speed of the red light. So the answer is the velocity of light for violet is less than. So B option is the right answer. B option is the right answer. So the next question reads out that. Let's do the next question. The next question reads out the engine has an efficiency of 1/6. So eta is 1/6. We know that eta is equal to 1 minus T lower temperature, that is the sink temperature by the source temperature. So eta we would have according to the equation, the eta is equal to 1 minus T lower temperature, that is the sink temperature by T source temperature, that is higher temperature. So this implies TL minus divided by TH is equal to 1 minus eta. First case eta is 1/6. So TL by TH is equal to 1 minus 1/6 is 5/6. Second case eta doubles. So in second case TL by TH, TL is decreased by 62. It is given that when the temperature of the sink is reduced by 62 degrees Celsius, TL by 62 divided by TH is equal to 1 minus eta is double. Initially eta was 1/6, so that will become 2/6 here. That will become 2/6 here. So this will become 6 minus 2 is 4, 4/6, which is 2/3. So you divide this equation. This is the first equation and this is the second equation. When I divide the second equation divided by the first equation, I will get TL minus 62 divided by TL is equal to 2/3 into 2/3 divided by 5/6, or I can write it as 2/3 into 6/5. So 3 cancels 2 times. This one becomes, it cancels 2 times. So this becomes 4/5. This becomes 4/5. So solving this, you should understand this. In this equation, I'm supposed to put the TL and TH in terms of Kelvin. It should be Kelvin. Only Kelvin you should use in this efficiency equation. The TL and TH are in Kelvin. Here it is given the increase in temperature. The reduced temperature is changed by 62. That is, it is reduced by 62. The change in temperature in Kelvin as well as in degrees Celsius is the same. So I can substitute this one. For me, if the change is 62 degrees Celsius is given, then the change in Kelvin is also 62 Kelvin. So TL minus 62 by TH is equal to 2/3. So you should understand that concept here. So solving this equation, you will get TL is equal to 310. You cross multiply this 5 makes it 310. This 5L minus this 4L will give you TL, 1 TL. 5 TL, this when you cross multiply, this becomes 5 TL. When you cross multiply, this becomes 4 TL. So when you subtract, it becomes TL. TL is equal to 5 into 62 is 310. So this is 310. So because the options are given in Celsius, I will convert it into Celsius. I have to subtract 273. So the lower temperature will be equal to 310 minus 273 is 37 degrees Celsius. So the lower temperature is 37. Here, if you see, they are asking source and sink. So sink only we have found. Sink is 37. Only one option is there with sink as 37. So this should be the right answer. Anyway, by substituting TL is equal to 37 in any one of the equation, maybe in the first equation, If TL is equal to 37, TH is equal to 37 into you can find a TH from this equation. You can find TH 37 into 6 by 5. You can always find what is TH here. So that is how you will do this problem. So the correct option is 1 here. This is the correct option. So let's do, this is the 5th question. Now let us do the 6th question. So in the 6th question, there are given two isotherms. The two isotherms, which is the correct answer? So here they're asking you which is the correct answer. Since this isotherm is far away from the origin, all the points in this isotherm will have the product of pressure and volume greater. We know that PV is directly proportional to temperature. We know that the PV is directly proportional to temperature. So we know that PV is equal to nRT. So PV is directly proportional to the temperature in Kelvin. So that means that every point on this will have the product of pressure and volume greater than every point on this, the product of pressure and volume on this point. That means that T1 is greater than T2. PV for this isotherm, which is far away from the origin, will always be greater than PV for this isotherm. So T1 is greater than, so T1 is greater than T2. T1 is greater than T2, which means the correct right answer is A. Which means the right answer is A. So next we will do this question. So during an experiment, during the experiment to determine the resistivity of a wire of a breather bridge, the jockey is moved gently along the wire from left to right. The purpose of moving the jockey here is to find the null deflection. So here the first option reads out to find a deflection in the galvanometer towards left. To find it, you are not trying to find any deflection here. The deflection will be already there. So you are finding the null deflection here. So the right answer should be this. C should be the right answer here. So C should be the right answer. This should be the right answer here. So that is a theory question. That's the basic idea of meter bridge. Meter bridge works on the principle of null deflection method. So next one, a circular head of a screw gauge is divided into 200 divisions. There are 200 divisions on the circular scale, and the circular head moves 1 millimeter for 1 revolution. That only you call it as a pitch. The distance moved by the circular head for 1 revolution, you call it as a pitch. So here pitch is equal to, in this problem, that is the problem number 8. In this problem, the pitch is equal to 1 millimeter. 1 millimeter, and number of divisions is 200. So number of divisions is 200. Number of divisions is equal to 200. So therefore, you can find the least count from this. The least count is equal to pitch divided by number of divisions. Number of circular scale divisions. Number of circular scale divisions. 200 divisions. So that is 1 millimeter divided by 200. So which is 0.005 millimeter. The least count is, we have found the least count. Now once we found the least count, in this problem they are giving the reading of the main scale reading and the circular scale reading is given, and also the zero error is also given. So the actual reading is equal to main scale reading MSR plus CSR, circular scale reading. The circular scale reading you will multiply by the least count into least count. Minus zero correction. So zero correction is negative here. So negative of negative will become positive. So what will be MSR? MSR is going to be 6 millimeter plus CSR is going to be 45. 45 into 0.005. So 45 into 5 will give you 225. So it will become 0.225. Yeah, 0.225. Minus zero correction. So minus zero correction is negative. So it will become plus 0.5. So when you, this is 6.225 plus 0.05 will give you 6.275. 6.275. So this is the right answer. 6.275 is the right answer. So we will do the next problem. Question number 9. So question number 9 reads out. Question number 9. The adjacent figure shows the position time graph of a one-dimensional motion of a particle of mass 4 kg. Mass is going to be 4 kg. The impulse at t is equal to 0. At this point, what is the impulse? Because here the position time graph is a straight line. It's a parallel to x-axis. That is the time axis. So here, the velocity is 0 here. In this portion of the graph, the velocity is 0. And similarly, in this portion also, the velocity is 0. This is also parallel to time axis. So velocity is 0 here. But here, the slope of this graph is actually 3 by 4. So the velocity of the graph here is 3 by 4 meter per second. 3 by 4 meter per second. They are asking impulse at t is equal to 0. Well, impulse, what is the impulse? According to impulse theorem, impulse momentum theorem, the impulse is equal to change in momentum. So at t is equal to 0. So the impulse at t is equal to 0 is equal to mass into change in momentum. That is mass into change in velocity. So change in velocity is final velocity minus initial velocity. V final minus V initial. V final minus V initial. So what is final velocity here after this? After t is equal to 0, the velocity is at this point, after t is equal to 0, the velocity becomes 3 by 4, and before it is 0. So it is 3 by 4 minus 0. So mass is going to be 4, and this is 3 by 4 minus 0 is 3 by 4. So you get 3 as the answer. So 3 is the answer. So you have 3 in option C as well as option D. It's very clear that the impulse at this point cannot be 0. So immediately you can say this is the answer. Anyway, we can find this also. The momentum as t is equal to 4 is equal to mass into, what is the final velocity here? Final velocity is 0 minus initial velocity is 3 by 4 in this case. So if this is 4 kg, if this is 4 kg, so this 4 and 4 get cancelled, then you get minus 3 here. And the unit of impulse is mass into velocity. So it is kilogram meter per second, meter second inverse. So next problem, we will do the next problem. Question number 10. Question number 10. Here, in case of question number 10, in this case, in case of a PN junction diode at high value of reverse bias, the current rises sharply. The value of the reverse bias is known as, it is Zener breakdown voltage. In this one, this is actually this one. There will be two values. This is called as Zener breakdown voltage. In forward bias, the graph goes like this, and this is called as knee voltage. This is called as knee voltage, and I think they call it as critical voltage also. This is called as a knee voltage, and this voltage is called as Zener breakdown voltage. For this, Zener breakdown voltage is the answer. So we will do the next question. The photon materializes into an electron and positron pair. The kinetic energy of the electron is found to be 0.19 million electron volts, which means that the kinetic energy of the proton, which has the same mass, positron, not proton, sorry, positron. The positron, and what is the electron and what is the positron? Electron and positron, the mass of electron and positron are same, but their charges are different. Charges are opposite to each other. This is so mass is same. If the mass is same, then the kinetic energy, if you conserve momentum and energy, the kinetic energy of this one should be the same as that of the positron, and the electron should also be same. So here, the what will be the mass of the photon? Photon was initially the photon. Now it annihilates into a electron and positron pair, which means that what will be the photon energy of the photon? Energy of the photon should be equal to that should be equal to the rest mass energy of the electron. The electron and positron will have the rest mass energy. The rest mass energy of energy of electron plus proton. Electron plus positron. Sorry, it is positron. Electron plus positron. So electron plus positron. plus the kinetic energy of electron plus positron, plus the kinetic energy of electron plus positron, plus the kinetic energy of electron and positron, kinetic energy of electron plus positron. So the rest mass energy of electron and positron is approximately 0.51. You can find the rest mass by using this equation. E is equal to mc squared. E is equal to mc squared. If you calculate the mc squared, that will come in joule. To convert it into, you have to divide it by E, that is 1.6 into 10 power minus 19. So this will be approximately 0.51. This will be approximately 0.51, slightly greater than that value. So mc squared divided by E, when you calculate, the mass of the electron, we all know that it is 9.11 into 10 power minus 31, and C is 3 into 10 power 8. The charge on an electron here is converting joules into electron volts. You have to divide by 1.6 into 10 power minus 90. When you do these all these calculations, you are getting approximately 0.51. So what will be the electron photons energy here? Photons energy should be equal to 0.51 plus 0.51, 2 times 0.51, plus kinetic energy of the electron and positron is given to be 0.19. So that is also 2 times 0.19. So this is approximately 1.1. 0.51 plus 0.51 is approximately 1. This one is 1.01 plus this one is 0.38, 0.38. So this will become 1.39 actually, 1.39 approximately, slightly greater than 1.39. So if you look into the option, so this should be the right answer. There is one confusion here. None is also given. This one approximately, this is, I told you, this is slightly greater than, you are rounding off. When you round off, this one is slightly, it's a 0.51, it's slightly greater than 0.51. I'm neglecting the other digits here. So when you put this is approximated to this 0.39, you are approximating it to 1.4. So you can give this as the right answer. Always in this JEE mains, you can round off the value and you can give that as the answer. This is the question number 11. Now next is question number 12. Question number 12 reads out, 10% of radioactive material decays in 5 days. Then the amount of original material left after 20 days. Here 10% is decays in 5 days. That means 90% of the material is remaining material. So we know that the N is the number of atoms remaining. N is equal to N naught e power minus lambda T. Lambda is the decay constant. T is the time taken. So when you substitute for the first is, according to the first is 90% is remaining. So that means 0.9 times N naught. This N is nothing but 0.9 times N naught is equal to N naught. This N naught gets cancelled. So I'm not writing that N naught both sides. So e power minus 5 days, 5 days is given. Time is 5 days. So this is 5 lambda. And the second sentence they are asking you how much original material is left after 20 days. So that one we know, I'm having it as x. X is equal to e power minus 20 lambda because it's 20 days is given. 20 lambda can be written as e power minus 5 lambda, the whole power 4. I can write this 20 as a 5 power 4, which is not actually e power minus 5 lambda power 4, which is nothing but e power minus 20 lambda. So e power minus 5 lambda value already I know to be 0.9. So this will become 0.9 the whole power 4. 0.9 the whole power 4. It's when 0.9 into 0.9 will give you 0.8 approximately. 0.8 into 0.8 will give you approximately 0.64 or greater than 0.64. So 0.64. It should be greater than this value. So we will look into the options. 64. So which is given in percentage. So it is 65%. This should be the right answer. Because all others are. This should be slightly greater. Because 0.9 into 0.9 is 0.81 actually. I'm approximating to 0.8 and calculating it to be 0.64. So I'm expecting an answer which is slightly greater than 64%. So this should be the answer in this case. Now next is question number 13. So everyone, see, well, let's read out this question. light of two different frequencies whose photons have energies 1 electron volt and 2.5 electron volt respectively successively illuminate a metal whose work function is the ratio of the kinetic energy. Kinetic energy ratio, the kinetic energy is equal to, we know that the kinetic energy, according to Einstein's photoelectric equation, I'm doing the 13th problem. According to Einstein's photoelectric equation, the kinetic energy is given to be the photon's energy, the incident photon's energy. The incident photon's energy, in this case, E of the photon plus work function. Sorry, minus work function. Minus work function. So first case, the kinetic energy K1 is equal to EP is given to be 1 electron volt and work function is going to be 0.5. So in first case, this is the photon's energy and this is the work function. So 1 electron volt minus 0.5 will give you 0.5. And second case, K2 is equal to 2.5. In this case, this is 2.5. So 2.5 minus 0.5 is 2. So we get K1 by K2 is equal to 1 by 4. Here they are not asking you the velocities. So suddenly don't give this as the answer. Sorry. They're asking you the kinetic energy means it's directly proportional to velocity. This because the formula for kinetic energy is half mv squared. So in this case, v1 squared by v2 squared is equal to 1 by 4, which gives you v1 by v2 is 1 by 2. So this should be the right answer here. This should be the right answer here. Now let us do this problem, the 14th one. The 14th problem, let us do the 14th problem. The 14th problem here, it is a kind of block on block problem. It is a kind of block on block problem. In case of block on block problem, this force will be directly applied to either this or this. In this case, there is a different setup here. So usually block on block problem, what will you do is, this is kept on a frictionless surface. This is kept on a frictionless surface. First, let us find what is the maximum. Here the friction is 0.6 is given. This is 10 kg and this is 15 kg. The applied force here is 80 Newton. So first we will find what is the maximum friction force between the 10 kg block and 15 kg block. So what is the F max? F max is equal to mu n. In this case, n should be equal to 10 g only. It should be equal to 10 g, which is 100. Mu is going to be 0.6. Because if you draw a free body diagram for the upper block, this will be mg and this will be n. This will be mg and this is n. So n should be equal to mg here. So that means that mu is 0.6. M is 10. So 10 into, I'm taking, they are given the value of g to be 10. So 10 into 10 is 100. So this is 100. So I get 60 Newton. So this is equal to 60 Newton. 60 Newton is the maximum friction force. Now, if the applied force is able to overcome this force, then we have to check that. What will be the friction force? If the friction force, necessary friction force is less than this F max, then both are moving together. So let us check that on here. So now let us assume that both are moving with the same acceleration. Let us assume, that is an assumption here. Let us assume that, both are moving at the same acceleration. Assume both moving with same acceleration. Same acceleration. So if both are moving with same acceleration, you will take the entire as one system. This entire thing you can take it as one system. This entire thing you can take it as one system. So this is the only applied force. So 80 divided by, so acceleration of the total system, that is both the blocks, will be 80 divided by, the total mass is 25. 80 divided by 25 is 3.2. This is my assumption, 3.2. Now this block is moving at 3.2. I will draw a free body diagram for that block. So this is also 80, because if this is 80, throughout the string it is going to be 80. So this is 80. This is 10 kg block. And let me consider the friction force acting on this is F. and this is moving with the 3.2. So I'll find what is the friction force acting on this. And if this moves at 3.2, so 80 minus friction force divided by 10 is equal to, that is the acceleration. Net force divided by mass is acceleration, that is 3.2. So F is equal to 80 minus 32. F is equal to the friction force acting on that is F is equal to 80 minus 32. 80 minus 32 is 48. So the friction force which is acting on the object is less than the maximum friction force. If this would have been more than, means then you can say that this friction force is only acting. That means that they are moving separately. The maximum friction force acts once the object starts moving relative to the surface. The maximum friction force once the object is about to start moving or moving relative to the other surface. In this case, this friction force is less than the maximum friction force. That means that the block is not, this 10 kg block is not moving on this 15 kg block. So our assumption that they are moving at the same acceleration is correct. So this answer should be the correct answer. So 3.2 is the right answer. 3.2 is the right answer. Suppose in this problem, this applied force is going to be something else, a higher value. Say if this is going to be 160 Newton, if they are giving this as 160 Newton, so this will be 160. Suppose I'm doing the other problem. If this is 160 Newton, so this would have been 160 and this would be 6.4. So I will substitute 6.4 and check. This is 6.4 and this one is 160. So in that case, this will be 160 and this should be 6.4. So in this case, F should be equal to 160 minus 64. That will be, in this case, what will be F in this case? F should be equal to 160 minus 64 is 96. So in this case, the friction force is more than the maximum friction force. If that is the case, then both the blocks will move separately. Both the blocks will move separately. Then how to find the acceleration means, you have to find the acceleration by drawing the free body diagram separately. So what is the max? Now you will consider this is the maximum friction force is 60 Newton here. And what is the applied force here? In this, the applied force is 160. In this, our new example, this is 160 Newton. I'm doing the other problem in which there is both the blocks are moving with separate acceleration. So these are the two velocities acting, two forces acting on this 10 kg mass. Now acceleration of this one should be 100 by 10. So 160 minus 100. 160 minus 100. The applied force is this is 160 Newton. This is 60 Newton. Friction force is acting. So 160 minus 60 by 10. So 160 minus 100 is 60, which is 6 meter per second square. So when you consider this other block, this block, so applied force is 80 Newton. And this force will be, if this is 60 is acting in this direction, here it will act in this direction. 60 will be acting in this direction here. This will be acting in this direction. So what will be the force acting? Here also there is some tension. So this is attached here. So a tension will be 80 and this is also 160 and 160 will be acting. Sorry, this is 160 in our new example. So this 160 and this 160 will get cancelled. So the only force acting on this one is 60. So 60 divided by 50. This will be 4 meter per second square. The second block, because this 160 is acting here. This pulley belongs to this block. So this 160 is acting backward. So this 160 and 160 will get cancelled. So the only force acting on this one is friction. So this block is moving only due to the friction force in this example. So this is a nice example for you to understand. I've done both the ways here. I've done one problem which is given here, for which the answer is 32. And I took another problem. What happens if this is 160 Newton? I hope you understand what I have done. So let us move on to the next question. Question number 15. Question number 15. Question number 15. Everyone listen. Here, the body of mass 5 kg is under tension, under the action of a constant force, this one, and T is equal to 0, the velocity is this one, and T is equal to 10, the velocity changes to 6G. The force F is equal to. We know that F vector is equal to change in momentum vector. So, change in momentum vector is mass into final velocity vector minus initial velocity vector by time. The mass is going to be 5 kg here. So 5 times final velocity vector is going to be 6J minus initial velocity is 6I minus 2J divided by time taken is 0 to 10, so 10 seconds. So this will be half times. So this is minus 6J. This plus 8J. Minus 6I, sorry. It's minus 6I. Minus 6I. Plus 8J. So that should give you minus 3J. Plus 4J. So this is the right answer. So here minus 3I. Minus 3I. I don't think the answer is here. So this is not the answer anyway. This is not the answer. Answer should be either this one. I think there is a printing error in this problem. Or you can even check what I have done. I hope I have done it right on my calculation. So I am getting minus 3I plus 4J. There is no option minus 3I plus 4J. So I think both are J here. I think this should be I. So this should be the right answer. That would have been a printing mistake here. Question number 16 next. Question number 16. Let's do question number 16. Everyone listen. The plate of mass M is placed on a horizontal frictionless surface. A plate is placed on a horizontal frictionless surface. This is no friction, mu 0. And a block is placed on it. This is going to be M and this is going to be M. The coefficient of dynamic friction is given. This is friction. This has friction. And the coefficient of dynamic friction is going to be mu. A force of 3 mu mg is applied to the body of mass M. I am applying a force of 3 mu mg. This is the applied force. Now this problem can be easily solved here. What is the maximum friction force between the two surfaces? What is maximum friction force between the two surfaces? That is equal to mu g actually. Mu into n. N is again equal to mg. So already I told you this is only vertical forces acting on it is mg and normal. So normal reaction should be equal to mg and mu should be equal to mu times n. Sorry, F max should be equal to mu times n. So mu into mg. So the applied force here is can overcome the friction force. So this is moving separately. So what is the what will be the acceleration of this mass? This mass acceleration should be equal to 3 mu mg. 3 mu mg divided by mu g. Mu mg. That is the sorry. 3 mu mg minus mu mg, that is the friction force, divided by total mass is m for that block. So that will be 2 mu mg. Sorry, this m will not come. 2 mu g. 2 mu g. That is the acceleration of the block, small block. Now, what is the force acting on the larger block? There is only one force acting. The friction force on this will be acting towards left. So the same friction force mu mg will be acting on this block of mass m towards its right. So here, what will be the acceleration? Acceleration should be equal to mu small mg by capital M, because only one force is acting on this block. So acceleration of capital M is mu mg by, so this should be the right answer. This should be the right answer here. So we will move on to the question number 16 here. Question number 16, 17 actually. Question number 17 here. two rods of length d1 and d2 and coefficients of thermal conductivities k1 and k2. We know that the rate of flow of the heat energy is dq by dt is equal to the area of cross section into change in temperature T1 minus T2 times eta divided by L. So now this one consists of two T1 and T2, K1 and K2, D1 and D2 and K1 and K2. Both are same area of cross section. So if I compare, in first case, it will be A times the difference in temperature, del T, into eta divided by length thermal conductivities. Yeah, L by K. L by K. K will come here. So this is only K, sorry. This will not be here. The K only. This K only is here. What I've done is right only. Instead of eta, they are giving you K here. So I'm substituting that K here. So in this case, it is D1 by K1 plus D2 by K2. D2 by K2. That should be equal to, if both are combined, then it is A times del T, and this will not be there, no? This will not be there. A times del T divided by A times del T divided by D1 plus D2, the whole divided by K is the effective thermal conductivity. So when you compare these two equations, you get D1 plus D2 divided by K is equal to D1 by K1 plus D2 by K2. This is a standard formula actually. K should be equal to D1 plus D2 divided by D1 by K1 plus D1. D1 by K1 plus D2 by K2. So this should be the right answer. Next, we will do the next question. Question number 18. A particle starts SHM from a mean position. Its amplitude is A. Its amplitude is A, and the total energy is E. At one instant of its, maybe this some printing mistake. At one instant, its kinetic energy is 3E by 4. Its displacement at this instant is. So we know that if the energy, total energy is MA omega squared. MA squared omega squared. MA squared omega squared. Total energy is MA squared omega squared. This is a total energy or maximum kinetic or potential energy. Energy at some instant is equal to some this energy of the particle at some displacement. Kinetic energy alone. Kinetic energy of the particle at some displacement y is equal to m omega squared into a squared minus y squared. So it is quite understandable here. At mean position y is equal to 0. So the maximum kinetic energy is m a squared omega squared. So you divide this equation. In this they are going to be 3e by 4. And they are asking you what is the displacement? 3e by 4. You can divide this equation divided by this equation or this divided by this. So I get this 3 by 4 is equal to m omega squared gets cancelled. By a squared. You can solve this equation. You get 3. This is 3a squared and this is 4a squared. So that you bring it to the other side, it becomes a squared is equal to 4y squared. So that gives you y is equal to 1 by 2, a by 2. Y is equal to plus or minus a by 2. So y is equal to a by 2. So this should be the right answer. This should be the right answer. Question number 18. Question number 18. Now let's do the next question. The question number 19. We'll do the question number 19 here. Two long parallel wires P and Q are both perpendicular to each other to the plane of the paper with a distance. So two long, I'll consider that both are moving in this direction. The current is flowing into the paper, perpendicular to the plane of the paper, distance 5 meters between them. So this one is 2.5. This carries a current of 2.5 ampere and this carries a current of 5 ampere in the same direction. Then the magnetic field at the halfway. At this point, what is the magnetic field? So we know that due to a straight wire, the magnetic field is mu naught I by 2 pi a. So due to this, it is going to be mu naught I. If the current is in this direction, here the magnetic field due to this one will be in this direction. Due to this one, it will be in this direction. It will be in this direction because you use this thumb rule. When you use the thumb rule, you get this in this direction, this in this direction. So it is due to 5 ampere, it is going to be mu naught I by mu naught 5. I is 5 by 2 pi. I have this distance as a. So this distance is also a because it's at the midpoint. 2 pi a minus a is going to be 5 meters here. I will let us substitute. Minus mu naught into 2.5 by 2 pi a. So this 5 minus 2.5 will give you 2.5. 2.5 mu naught by 2 pi, a is 5. A is 5. So what will be the answer here? This 5.5, so 1 by 4. So we will check what we have done. Mu naught I by 2 pi a. Distance between them is 5 meters. So this should be 2.5, no? This should be 2.5. This is half the distance. This should be 2.5. So I'll make that correction. This is 2.5. Because the total distance is 5. The total distance is 5. And so this distance should be 2.5. So I will score out this 2.5. So I'll get mu naught by 2 pi. So this should be the right answer. So the next question, we'll do the next question. So listen to the 20th question. 20th question. In a circuit, LCR are connected in series with an alternating voltage source of frequency F. The current leads the voltage by 45 degree. If the current leads the voltage by 45 degree, this is quite easier problem. No, this is straight away equation. We now get tan phi is equal to XL minus XC by R. So you straight away substitute this one. In this case, maybe current leads in the null, you can have this as C and this as here. This you can have it as here. Because this current leads the voltage here. So XC and XL. This is XL. So you can, this is 45 degrees. So this is going to be 1. So R should be equal to tan 45 is 1 here. So this R I'm bringing to the other side is equal to XC minus XL. So R minus R is equal to XC is 1 by C omega minus XL is L omega. So this one I can write it as 1 by C omega is equal to R minus L omega. Or C is equal to 1 by omega times R minus L omega. Instead of omega, if you substitute 2 pi frequency, I'll get this as the answer. I'll get this as the answer. I'll get that as the answer. So next is 21st problem. An insect is trapped in a circular groove of 12 centimeter, moves along the groove steadily and completes 7 revolutions per second. So the frequency is 7 revolutions per second. So omega is should be equal to, here the frequency is going to be 7 revolutions per second. If you want to convert that one into 7 revolutions per second, if you want to convert that one into radians per second, that will be equal to, that omega will be equal to 2 pi into 7. 2 pi into 7. 2 pi times frequency, radian per second in this case. So this is omega. What will be its linear speed? We know that omega is equal to V by R. V by R. So V should be equal to omega into R. Omega is 2 pi into 7. R is 12 centimeter. You can calculate this value. You can calculate this value. So V is equal to R omega. Omega we have put 2 pi into 7 into R is, you can calculate this. This is 22 by 7. No? You can calculate, strike this one and you multiply 122. So now 22 into 2 into meter per second square. Meter per second. That is the linear speed here. So what should be, this should be 24 into 22. So you can calculate this one. So that is the answer for this 21st question. Now next is 22nd question. The radius of curvature of a thin planar convex lens is 10 centimeter and the refractive index is 1.5. The radius of curvature is 10 centimeter. Planar convex lens. It is going to be planar convex lens. This R is going to be 10 centimeter. R is going to be 10 centimeter. The refractive index is going to be 1.5. Refractive index is going to be 1.5. If the plane surface is silver, here it is silver. Plane surface is silver. The plane surface is silver. Then it behaves like a concave mirror of focal length. What is the focal length of this one? They are asking what is the focal length of this one. Now we can easily find this one. So we know that 1 by combination of a silver mirror is 2 by f lens plus 1 by f mirror. All silver lens formula this one. 1 by f mirror. Here, since it is a plane lens, it's a plane mirror, sorry, this should be 0 because Fm should be infinity. So Fl should be equal to Fl focal length of the lens by, this is combination, sorry. This is combination. This is Fc is equal to Fl by 2. We know that the Fl for a planar convex is mu minus 1 by R. Mu minus 1 by, in this case, this is 2R. So that will be equal to, R is given to be, Fl is 1 by, I done a mistake here, Fl is equal to 1 by, so this should be equal to, Fl should be equal to, 1 by Fl is actually, 1 by Fl is mu minus 1. Mu minus 1 by R for a planar convex. For a convex, it is 2 by R. Mu minus 1 into 2 by R. For a concave, it is minus 2 by R. For a planar concave, it is minus 1 by R. For a planar convex, it is 1 by R. So this is the formula for planar convex. So Fl should be equal to R by mu minus 1. So this should be R by 2 times mu minus 1. So that should be equal to, what will be this one? This should be equal to, what is R? R is equal to, R is going to be 10. This is 1.5 minus 1 is 0.5, 0.5 into 2 is 1. So 10 should be the answer for this one. This is 10 should be the answer. Next to 23rd question. I'll erase a part of this question. So 23rd question. two blocks A and B of 10 kg and 5 kg respectively. This is 10 kg and this is 5 kg. Respectively, shown as shown in the figure, the coefficient of friction between the table and the block is 0.2. Table and the block. This and this is 0.2. The minimum mass M, so that it prevents from sliding. So this is so what will be the force here? This force should be equal to 50 Newton, 5G. So this also should be equal to 50. This also should be equal to 50. And if we consider the maximum friction force is acting on this one, this should be equal to mu n. Here n should be equal to mass of A. Mass of A is going to be 10 kg. 10 plus that unknown mass into G. So for this to just to move this one, so the applied force 50 Newton should be equal to the friction force mu n. Mu times 10 plus m into G. So here the mu is going to be 0.2, G is going to be 10. So this will give you 2. So this is 25. This is equal to 10 plus mu. 10 plus m. So m should be equal to 15 here. The answer should be 15 for this one. That should be the answer for that. So we'll do the next question. An ammeter and voltmeter are ammeter and voltmeter thing is 0.25 and 0.5. They are asking you what is the resistance of the, by using Ohm's law. This is a straightforward, this is a high school question. So R is equal to V by I. V is going to be 5 and 0.5 and this is 0.25. 0.5 and this is 0.25, which is equal to 2. So that is a straight away question. This is 2. 25th question. The wheel is rotating at 900 RPM, revolutions per minute. That means initial velocity is 2 pi into 900. You are converting into radians per second. 900 into 2 pi. If I convert it into seconds, by 60. This is radian per second. And if the power cuts off, it comes to rest in 1 minute. So omega final is, after some time t, it comes to rest in 5 minutes. In 1 minute, that is 60 seconds. Sorry, this is 0. Time is 60 seconds. So they are asking you what is alpha. Alpha should be equal to omega t minus omega naught divided by time. So omega t is 0. So that is, so this should be 900 into 2 pi divided by 60 divided by time is also again 1 minute, so 60 seconds. 1 minute, yeah, 1 minute, 60 seconds. So this one and this 2 gets cancelled. So this is 18 actually. 18 and 6 cancels 3 times. So you get 18 pi by 36, which is pi by 2. 18 pi by 6 are 36, 9 2s are 18 pi by 36, which is equal to 1.57. So that should be the answer for this one. So that's the end of the paper. So see you with next paper very soon. Thank you all for listening.